has a local maximum or minimum value at an interior point C of its domain, and if f prime is defined at C, then f prime of C is equal to 0.
So back to our second function, f of x equals x squared, we now have an interval where it's closed. So since we put an interval on this, imagine this as a snippet from a larger function. So with this, we will now have a relative or local maximum at y equals 4 here, and a local or relative minimum value at y equals 0.
The only place where a function f can possibly have an extreme value, whether local or global, are at 1. Interior points where f prime is equal to 0, f prime is undefined, or at the endpoints of the domain of f.
So here are some examples of having an endpoint where it can be your absolute maximum and absolute minimum. So here you have neither an absolute maximum or minimum. But if you were to change this here, you have an interior maximum here and a absolute minimum at the endpoint. But if you were to change the graph like this, you will have two interior points or two interior critical points with a maximum here and a minimum here.
An interior point of the domain of a function f where f prime is 0 or undefined is a critical point. Most problems that ask for extreme values call for finding the extreme of a continuous function on a closed infinite interval.
So to find a critical point, you need to find the derivative of a function where it equals 0 or is undefined. So for an example, we're using f of x equals 3x cubed minus 9x plus 3. So we're going to start by finding the derivative of this function. So f prime of x is equal to 9x squared minus 9 equals 0. So now that we have this, we're going to solve for x. So we're going to have the 9x squared equals 9, x squared equals 1, x equals plus or minus 1.